Sunil sir, shall we start?
Okay, ma'am, ready. I'm ready.
Okay. Good afternoon, all. Let's move on to the next technical session of the day on the topic Flying Robots How to Build a Drone by Mr. Sunil Paul. Mr. Sunil Paul, a college professor and an entrepreneur, is currently working as the director of Christ Center for Innovation and Open Learning at Christ College of Engineering, Iranyalakuda, Kerala. He is a postgraduate gold medalist from SRM University, receiving an MTech in robotics. Sir is an innovator and the co-founder and CEO of Srishti Robotics Technologies Private Limited, Kochi, and mentors a couple of other startups as well. Under his leadership, Srishti Robotics received many national level recognitions in the past 3 years. Srishti Robotics was rated as the top 10 most promising robotics training institute in India in the year 2018 by Higher Education Review. It was again rated as India's 10 most prominent certification courses and training providers in the year 2019 by the Knowledge Review. In the same year, Srishti Robotics again found its place among the 10 most promising STEM education institutes by Silicon India. Over the last 12 years, nearly 15,000 students have been benefiting from the robotics classes taken by Sir, and Sir has conducted more than 100 workshops at engineering colleges, arts and science colleges, medical colleges, dental colleges, and schools. Students from middle school to professional courses have participated and won prizes in many national and international robotics competitions under his guidance and support. He encourages and motivates students to become innovators by introducing them to the various tools of robotics. Very happy to have you, sir, for our STP program. I kindly invite you for the session. Over to you.
Thank you, ma'am, for the wonderful introduction. Thank you very much. Good afternoon, everyone. And today morning, we had two excellent sessions. One about robotics, and then second one about AI, and the second one about robot operating system. I enjoyed both the sessions, and today afternoon this will be a very light session. Okay, I'm not going to talk about too much about technology. So the ultimate objective of this session is to understand basic drone. Okay, today I will be talking detail about quadcopters. Okay, drones with the 4 rotors. Then we can see what are the other type of drones available. Then few commercial applications. Then one about the tethered drone, and ultimately I will discuss more about from where we can buy components, what are the components you have to buy, how easily you can build a drone, and at the end I will try to fly my drone in my lab. Okay, I'm sitting here at the lab of Christ College of Engineering, Iranyalakuda. Okay, my basic lab. So I have a drone here. So I will explain using that drone today's session. Okay, so I will share my screen and I have a presentation. So that presentation is simply few pictures, and I will explain the components. Then later we can see what is actually the real drone, and then we can learn a few things practically. Okay, so now I think some of you might have got the videos of Intel. Okay, Intel, they have a team. So 1 second. Okay, they have a team with the drones. They usually do drone shows. Okay, so I will play that video first, and this is a Christmas time, isn't it? Okay, so here you can see a set of drones. See a set of drones performing. Okay, in a street. Okay, so the system is developed by Intel. They have a set of drones with the GPS navigation, so they can pre-program the positions of all the drones, and they can control the light. Okay, drones with a different light, and you can set the position in 3D space by using the inertial navigation system. The basic, you need the 3-axis accelerometer, 3-axis gyro, then magnetometer, and then you need the GPS. Okay, they have a barometer. Okay, for the height measurement. So you can do different combination of the position. Okay, virtually you can draw anything in 3D space using drones. Okay, so this is what we are expecting. A drone session. Okay, sometimes people may expect that we can make similar things, but it's a little difficult. Okay, I really like to make this type of combined drone, the combination of drone system. Okay, but so first we have to learn how to build the same simple drones. Then later, so this is a combination of many drones. They are using a common software for continuously controlling the position of all the drones, the swarm system. Okay, swarm robotics. So this is what Intel do. Okay, we can go back to the presentation. 1 second. Okay, PPT. Okay. So this is the picture from picture. This is a very old picture. So 1958. Okay, at the time when US company tried to this Curtiss Wright, that's actually a brand. They designed a system VZ7. This is actually engine based drone, engine powered quadcopter. Okay, one person can sit and drive. Okay, sit and fly. Okay, so this is actual system. So this one developed for US military force, but they tested it for 2 years time, and since it was not meeting their requirement, they stopped the project. Okay, so right now we are talking about this type of drones. Okay, so this is one of the commercial product by DJI. So this is actually a Chinese brand. Okay, so I know some of the people are against the Chinese brand, but they do extremely well in technological developments. Okay, so this is a drone which can carry 20-liter pesticide, and you can cover an area of around 12 hectares per hour for pesticide spraying. Okay, that's actually if you're using a manual labor, he can actually cover around less than a hectare per day. So the system can cover 12 hectares per hour. Okay, it's almost much higher efficient than a human operator, and it can cover the entire area since it is flying with a map. Okay, autonomous drive. Okay, this is a waterproof, dustproof, IP67 rated device, and here you can see another application. Okay, these are not only used in paddy field, even you can use it in any other area. So initially, here in this picture, you can see left side, you can see one small drone. That's a DJI Phantom. Okay, we usually fly the smaller drone with a set of cameras. Then from that camera, we will get the 3D image of the entire area. We can identify different trees and trees position and its size also. Okay, height, width, everything. So based on that, they have a software called Terra. Okay, Terra is used for planning the path. Okay, so then they have a agriculture platform. Okay, for planning the drone movement. Okay, so it will actually follow only the trees, and it will spray only on the trees. Okay, not on land. Okay, so this is extremely good. So you need one drone for taking the 3D image, and the remaining the second drone will do the pesticide spraying. Okay, you need only one person to operate all these things, and the efficiency is very high. In Kerala, in our situation, this may not be that much useful, but in places like Rajasthan, Karnataka, they have thousands of acres together. They do the cultivation. So in that type of area, if you have a drone like this one, you can cover a lot of area per day. Okay, and getting manual labor, it's very difficult. Okay, it's very easy to do pesticide spraying with this type of drones. Okay, so here you can see the path what you are getting from the software. Okay, first picture from the phantom drone. Actually, the software will plan the path. Okay, based on the tree position. Okay, then the second drone will do the spraying. Okay, so they have this type of additional technology with them. You have a camera on the drone. Okay, usually in this type of system, we usually keep a camera for the live feedback. Then we definitely need a radar, because in autonomous navigation, sometimes the electric poles will be there at the farm. Be able to identify that and avoid that obstacle. Okay, so there may be some trees in between that also you can identify. So in this picture, you can see the top right picture, you can see some red markings. Okay, the red markings shows the obstacles. Okay, so I'm not branding, but they have very good technology. Okay, so this is the remote control they are using. So they have a remote control with the screen. Okay, you will get the data with the map as well as live feedback. In the bottom right, you can see the live video feedback, and you have two joystick. Then this RTK is for perfect positioning. Okay, so real-time kinematics device. Okay, that's for the perfect positioning. Okay, so this is about one type of drone. Okay, one type of drone application. So what are the components we need to make a drone? Okay, so we'll start with the battery, because all the drones we need battery for powering that one. So the battery will be connected to a power module. Power module is used for measuring the voltage and current used in the drone. Then we will get an output from that one for powering the flight control unit. Okay, so battery will be connected to the power module. From the power module, will give power to electronic speed control, ESC. Okay, or a motor driver. Okay, that actually connected to the brushless motors. This type of motors, since these motors are using very high current, with the brushed motor, it is very difficult to get that much power from a small form factor. Okay, then the motor is connected to propeller, and this brushless motor, the electronic speed controller will get data from the flight controller, how much the RPM required. Okay, that data you will get. Then you have an RC receiver that will be connected to the flight controller for getting the. So I will show you all those connections. Okay, then from the remote control, you are getting the data to the RC receiver. Then you need a battery charger, then battery monitor and frame. Okay, so we can see one by one. Okay, so this is one of the type of battery. Okay, this basically we use lithium polymer battery. Okay, now the latest technology is lithium polymer high volt battery. Okay, so lithium now I think in drone technology, in drone division, people are all concerned about the efficiency of the battery. Okay, so previously it was lithium polymer battery. Now it's lithium polymer high volt battery is used. The voltage rating is slightly higher than the normal lithium polymer battery. Okay, so in this one, in the picture, you can see a battery with 6 cells. Okay, a single cell of this battery, this having 6 layers, 6 cells are there. Single cell average voltage 0.7. Okay, so if you have 6 cells, you will get 22.2. Since it is a high volt battery, you will get 22.8 volt. Okay, that's a regular voltage. But if you charge a normal single cell, okay, the maximum voltage will get up to 4.2 for lithium polymer battery. Okay, so for lithium polymer high voltage battery, you will get 4.37 volt. Okay, 4.37 volt per cell into 6 cell. Okay, it's almost done. That's we usually tell that 12 volt battery, 24 battery, since the lead acid battery is classified into that category. Okay, so this is something similar to a 24 volt system. Okay, then you can see another rating 2500. There's a 2500 milliampere is the current rating. 2500 milliampere the battery can provide continuously for an hour. Okay, And you can see another number called 10C. Okay, so the 10C means suddenly if you need higher current, okay, the system can give 25,000 mAh, that's a battery. So it's almost 25 ampere output, not 2,500, 25,000 milliampere. So 25 ampere battery. So it is a 10C battery. That means you will get a total power output 25 into 10. That's 250 ampere current you can drain from a single battery. Okay. So most of these drone motors are high capacity motors. Take 30, 40 ampere current for driving. Suppose you have a 4 motors with a 40 ampere current rating, then you need total 160 ampere supply from a battery. Okay. Only lithium batteries can provide that. Otherwise, you need a very huge battery. In lead acid type battery, you know the difference because the size is huge. You will get power for longer time, but taking a higher current, this type of a current, for a short time, it's not possible from lead acid battery. So the advantage of lithium polymer battery, you can continuously give high current. Okay, 25 into 10, this 250 ampere current you can drain from this battery. Okay, and the major issue, if there is any short circuit, then again the heat produced will be I square RT. Okay, if it is burning, then the burn will be very severe. Okay, the temperature, total heat produced will be very high since the current is very high. Okay, so you have to be very careful when you're using this battery. Okay, and this is the second unit. This is not battery, this is the power module. Okay, so power module, you can give one side to the battery, the other side to the flight control unit power supply. And then you're getting some 8 or 6 wire connector. So this will be connected to the flight unit. Okay, for monitoring voltage and current as well as for power in the electronics. Okay, then next part is an ESC. So this ESC means this is an electronic speed control unit. So this is the motor driver. So brushless DC motor is something like an AC motor, 3-phase AC motor. Okay, so this ESC is getting 2 wire input. So you can give positive and negative from the battery. And you can see another small 3-wire connector. 3 wires are there. So that will be connected to a microcontroller. So from the microcontroller, you will get the data. Okay, how much should be the RPM? So based on that, we have a 3-wire connectors. You can see the other side, right side. That will be connected to a motor. Usually the brushless DC motor is having 3 wires. Okay, so this is something like a 3-phase AC motor. Okay, so I will show you one motor. Okay, so I will open a video. Okay, so this is slightly different from regular brushed motor, and this motor is an outrunner motor. I will explain why it is an outrunner motor. Okay, so see, this is a small motor. So this having this around more than 100 watts capacity. Motor. So this actually the outer side is rotating. So this motor is known as an outrunner.
Sir, actually,
Outrunner motor.
Sunil sir, sorry to interrupt. Sir, the video is
I hope you
getting
can
stuck.
see the screen.
Sir, the
Okay.
video is
So this
getting
is an
stuck.
outrunner motor. The outer side is rotating. The outer side is actually
Hello?
outer cover that contains a set of magnets. Actually, the coil is fixed to the main frame. The coil is not rotating. That is directly connected to the electronic speed control unit, and the outer side magnet is rotating. In regular case for the brushed motor, magnet is in fixed position and the coil is rotating. So you have to continuously power the coil using brushes. Okay, here no need of any brush since the magnet is moving. Okay. Okay, can you hear me now?
Yes, sir. We
Hello.
can hear you, but before the video was getting stuck, the second screen, when you opened the second screen, the video was getting stuck.
Hello.
Hello, sir.
Okay. I have a network issue right now
Yeah.
because
When
I'm
you
calling
opened
from.
the second screen, the video got stuck, sir. Now, when you were like this,
Okay,
it was fine.
okay. So maybe the other one taking too much of.
Yeah.
Okay, that may be taking a
So
little
when
more
you're
bandwidth.
explaining, I think if you wanted to demonstrate something, you could pin so that we can see in a
Okay,
bigger.
okay. That's
Thank
better.
you.
Okay,
Yeah.
so I will share my screen and explain the remaining. Okay. Okay, so this one here you can see the brushless motor. So this is an outrunner motor. The outer side is rotating, not the inner shaft. Okay, so the outer side is rotating, and here you can see the inside. There is no movement for the coil. Okay, there is no movement for the coil. Only a magnetic part is rotating. Inside this drum, magnetic pieces are actually sticked. Okay, that is only rotating. Okay, so. In a very small form factor, you will get a very high power. Okay, so uh, for a 10 centimeter diameter motor, even you will get around 3000 watts, 4000 watts motors. Okay, so okay, I'll go back to the presentation. Okay, so we have the ESC. ESC is having three conductors. Okay, that will be connected to the motor, and this is a small brushless DC motor, and this is by T motor. That is again a Chinese brand. Okay, so you can see the three connectors, and the outer part will be rotating. Inner coil part will be in fixed position. Okay, so these are the propellers. Okay, we need propellers, and for this brushless motor. If you see on the picture, you can see the number MT3506, then hyphen 25. There is actually another number called KV650. Okay, when you're purchasing a brushless DC motor, this KV value is also very important. Okay, the KV value is actually KV is a factor. Okay, how much RPM you will get per volt. In this case, in the motor which I have right now in my hand. Okay, this is a 1400 kV motor. That means per volt this will rotate 1400 rotations. Okay, so suppose you are giving 10 volt, then the RPM will be 14,000 RPM. And in this case, in this picture, you can see this motor is having 650 kV. So the kV value is less. That motor is slightly bigger one. kV value is less. Uh, for for 10 volt, this will rotate only 6,500 RPM. But this type of lower kV value motors with a higher torque. That means you can have a longer propeller, bigger propeller. So the drone will be much more stable. Okay, the stability will be high with the longer propellers. Okay, so these are the propellers. For the propeller, we have two numbers usually. The length will be there, 10-inch propeller. Then the pitch, 4.5, 6.5 in that way. The pitch means in air, this act is something like a screw. Okay, so if you are rotating the rotor single round, okay, this will climb this 4.5 inch. Suppose you have a rotor with a 10 by 4.5 number, that means 10 is the 10-inch length, and 4.5 is 4.5 inch that will advance in air if you are rotating one round. Okay, that usually that won't happen. That is actually a theoretical value. Okay, so if the pitch is very high, then you need lower RPM. Okay, if the pitch is very low, you need higher RPM for pushing the same amount of air. Okay, then you have the flight control unit. Okay, flight control unit. This is an RDU copter brand, RDU pilot, and this one contains an Arduino Mega microcontroller. You can see multiple connections. One side we will connect the remote control receiver, and the other side we will connect all the motor output, ESC connection. Okay, electronic speed control unit connection. Okay, then you can connect different type of sensors too. Okay, I will show you this one in my drone minute. Then I will explain all the components. Okay. Then you need an RC receiver. So this will be acting as a communication link between the remote control and the flight control unit. Okay, the receiver can receive the data and give the information to the flight controller. Usually this type of receiver can receive data up to 1.11 kilometer line of sight. There are remote controls with a 2 kilometer, 2.5 kilometer range. Okay, so I will show you a remote with a 1 kilometer range today. And this is a remote. This is Fly Sky brand. Very cheaper remote control. This cost only under 5,000 rupees. Okay. I started doing aero modeling. I think in 2008 I started doing that. At that time I purchased a remote control which cost at that time around 35,000 rupees. At that time I was teaching in a college. My salary was around 16,000 rupees. Okay, that was equivalent to 2 months of my salary for a remote control. But right now a lot of people are using this one. So the cost is very less right now. This costs less than 5,000 rupees. You will get 6 controls, 6 channel remote. Okay. Then you have the battery and battery charger. So before that, I will show the drone. Then I will explain all the part one by one. Okay. Okay. So I have my drone with me. I hope you can see the screen.
Yes, sir.
Okay. So we can start from the first part. Okay. And this is the size, length of my finger. Okay. So that's the size. And length is approximately 10 centimeter. So this is a 4200 mAh battery. That means 4.2 ampere per hour battery. This is a 6 cell. Okay, 22.2 volt output. And I have the connector, output connector, and this is my power input connector. And here you can see this is a slightly old drone. I made this frame in 2011. Okay, so this is my power module. So the battery will be directly connected to the power module. Power module, the data goes to a power adapter. Okay, so this is a power distribution board. Okay, so I connected all these wires a little bit thicker wire. Hello, I have still I have network issue.
So yeah,
I'll connect my laptop back again.
Okay. Hello, sir. Sir?
I can hear you now. Hello.
Yeah.
Sorry for the disturbance.
No problem, sir.
Okay. So here the network is very poor right now. Today LAN is not working properly in this area, and from my laptop, actually from my mobile, I am tethering. Okay, so I will explain this one. Okay, so from the battery that goes to the power module. From the power module, we have the power distribution board. So I'm using all thicker wires for the connection. So it is very difficult to connect all the things together to the power output of power module. Okay, so we usually use a battery distribution power distribution board. From multiple points, you can take the positive and negative output. We actually seal that area with a glue gun or silicon after all the connection, because there's a chance for short circuit. Okay, so all these motors are connected to a device called the electronic speed control unit. Okay, this type of device. So the rating, this can actually give up to 30 ampere current. So that the value of the electronic speed control unit, that depends on the motor type. Okay, so my motor required 30 ampere current peak. So I'm using a 30 ampere motor driver. I need 4. Okay, 4 unit for 4 of my rotors. And here you can see the input. It's actually 2-wire system. So I'm getting the positive and negative, and I have the signal wire to this one. So this is connected to the flight control unit. Okay, this is my flight control unit, and ESC, one wire is actually going from all the ESC, one set of wire. Okay, this is coming 5 volt ground and a signal, and there are 2 type of ESCs. So this in this ESC, this is a professional quality ESC. So there is no 5 volt output we are getting from the ESC. Okay, most of the time for the smaller capacity drones, along with the speed control unit, you have a battery elimination circuit called a BEC. Okay, battery elimination circuit. If you have the BEC in your electronic speed control unit, you will get 5 volt and ground supply, 5 volt and ground output from this electronic speed control unit. You will get up to 2 ampere current. Okay, so since the power is 2 ampere, that is enough for controlling your basic sensors and the flight control unit. Okay, so if you don't have the BEC, battery elimination circuit, in your electronic speed control unit, you definitely need this part. Okay, since I don't have the BEC, then I have to use power module for powering my flight control unit. Okay, so here you can see the connection coming out from the power module to the RD pilot. Suppose you have a battery elimination circuit in your ESC, so no need of connecting this one. You won't be getting any voltage current feedback, but you will get power to this RD pilot from the ESC. Okay, so you need 5 volt for driving that one. Okay, so you have the battery connected to power module, then to the battery power distribution board, to the ESCs. Okay, for ESCs are having 2 set of connection. One to the microcontroller unit for getting the data, okay, about the speed. Okay, and the second one, here you can see the 3-wire output. Okay, this is something like a three-phase AC supply. Okay, 3-wire. Here you can see that 3-wire output that is connected to the motor. And here in the section of motor, we have the propeller, which is directly coupled with the motor. Most of the time, for the lower capacity drones, there may be a nut and bolt system, something similar to the previous motor. Okay, so type of system. Okay, to the shaft you can actually connect the propeller directly. Okay, this type of system. But in this case, the problem with this one, the center shaft diameter may not be exactly perfect with the propeller center hole diameter. So if there is any slight variation, then that will result in unbalanced force in the system, and then the propeller may not be exactly at the center. Propeller center and the motor shaft center may not be exactly the same. So that will result in vibration. Okay, that vibration results in, sometimes that will damage all the nut bolt system, and this vibration again makes some issue with the flight control unit, because your flight control unit is having a accelerometer, so your accelerometer will get wrong data. Okay, so you have to isolate that one. So it is better to use standard quality propeller and the motors also with a very good quality. And there is a method called balancing propellers. Okay, so this is a carbon fiber propeller. So these are already balanced propellers. So this one is having center two screw system. So this is very stable, and you can see when the motor is moving, motor is rotating, the inside coil is in the fixed position. Okay, the coil is actually not moving. Okay, only the outer frame is moving. This outer frame contains a set of around 42 numbers of small magnets. Okay, it's very difficult to open it and show you the magnets. And the efficiency you can actually increase by reducing the space between the coil edge and the magnet. If you see the new type of high efficiency motors, you can see the spacing between those two are extremely low, and the magnet also not rectangle of shape, and they usually make it in arc shape. Okay, the curved shape of magnets they are using. Okay, so this is about the motor, and this motor is a 340 kV motor. So kV value is very low. Okay, it's a small thinner type of motor with a slightly higher efficiency. Actually, I purchased this motor long back, and single motor cost almost 7,500 rupees for a motor at the time. We tried this one for high efficiency flying. Okay, for getting maximum flight time. Okay, there are different type of motors for high power as well as high efficiency. So these are high efficiency motors. So we started from battery, then the power module, this power distribution board, ESC to the motor. Okay, and ESC is getting the other part. ESC is getting data from the flight control unit. Okay, so there is actually a question there. In the high current, how we are actually going to deal with the short circuit of any kind of issue. Okay, that was actually there is a question, short circuit. Okay, so in this case there is no chance for a short circuit, because in brushed motor, because of the brush, we can see most of the time the spark is coming. Okay, in this case there is no brush. Okay, we have this electronic speed control unit. So inside this you have 6 MOSFETs. Okay, for controlling the direction and driving the motor in clockwise and anti-clockwise direction. Okay, 6 MOSFETs. So there is very less chance for short circuit. If there is any short circuit, the problem that exactly the short circuit point will get nearly 150 ampere of current. Okay, so that's the issue. So whenever you're building the drone system, you have to make sure that all the connections, everything is perfect. If possible, you ask any one of your friend to check it again. Okay, most of the time it's very difficult to identify our own mistake when we are doing. So what we usually do is we'll ask a second person to check the circuit. They can easily identify the errors. Okay, so we'll come back to the flight control unit. Okay, so this is the flight control unit, and this is simple. There are different type of flight controllers. So I'm using I usually use 2 type of flight controllers. One is RDO pilot, and the second one is Pixoc. Okay, so this single unit cost around 2,500 2,600. So in this next phase, we will check all the components from where we can buy and what is the cost of each and every component. Okay, so this one costs almost 2,800 rupees, and this will do the basic purpose. Okay, so this is the output area. I have 4 rotos, so this is a quadcopter. Then so I'm using 1, 2, 3, and 4. Okay, 4 outputs. Octacopter, you will have 8 motors. Then you can connect up to 8 motors. Okay, so then you have the input signal input. So for driving a quadcopter, we need to connect up to channel 5. Okay, I'm using 1, 2, 3, 4, and 5. Up to channel 5, I'll show you what is actually channel 1, 2, 3, 4, and 5. Then I will explain the remaining. Okay. So this is a remote control we usually use for driving the drone. So I have the on button. Okay. So this is the power on. Then in the right side, this is my left and right movement. Okay. Left and right movement. This is my channel 1. Okay, so this is a left and right movement, channel 1. This is my forward and backward. That's my channel 2. and this is a speed control throttle. Okay, my channel 3 and left and right. This is my channel 4. Okay, so when you're flying the drone, this configuration is known as the type 2 configuration, where I'm using my left hand for giving the throttle. Okay, so this is my left hand. Okay, so my left hand is used for giving the throttle. Okay, in my because of the camera, I think left is showing us right side in the video. So I'm using my left hand for giving the throttle. That is type 2, and if you're using the right hand for giving the throttle, you have to reconfigure this one. There is actually a spring inside that you have to remove from this channel and put it into this channel. Okay, physically you have to change. Then you have to change the software. Okay, so sometimes people are actually good with controlling the direction with the left hand. Most of the time that happens with the left-handers. Okay, for them the direction control is easy with the left hand, so you can change that one. So that is known as the type 1 configuration. So I have a type 2. Left and right is my channel 1, forward and backward is my channel 2, throttle or speed is my channel 3, and if I'm using the left and right of my left side, I can actually rotate the drone from the same point. Okay, clockwise and anti-clockwise. Okay, these are the 4 connections, the bare minimum 4 connections you need to fly the drone. Then other than that, there's actually a switch here. Okay, so this is my channel 5. Okay, up and down. Okay, so this is used for selecting the mode. Okay, your drone you can fly in different mode. Okay, the simple mode is used for taking off. You can actually change the mode and you can actually loiter. Okay, keep the drone at a specific point. That will maintain the point. Then if you're interested, you can connect one more switch on the other side. Okay, this is channel 6. Okay, by using channel 6, you can add additional modes like GPS and enabled flying, autonomous flying, like that. Okay, all those things you can do with the mode selection. Channel 5 and 6 are used for mode selection, and remaining these 4 channels are used for driving. Okay, there is another next question: how to distribute all the weight equally in the center? Okay, in this drone, no need to distribute the total weight at the center. If there is any unbalanced force, for that we have the flight controller. Okay, so the flight controller, what the flight controller will do is, they have the flight controller. Inside the flight controller, we have a microcontroller, Arduino Mega in this case. Then you have 3-axis accelerometer, 3-axis magnetometer, and 3-axis gyro. Okay, by combining all this, then a barometer. Okay, this having 10 degree of freedom. Okay, 3-axis gyro, single axis barometer, 3-axis magnetometer, 3-axis accelerometer. Okay, by combining all these things, the drone can actually identify which side is heavier, which side is lighter. All these things the drone will identify. And if you're not giving any signal, the drone what it will try? The drone will try to keep the position in level. Okay, suppose you have a higher weight at this side. What happens? Automatically the RPM will be increased. So in this software, the software will check the sensor data whether it is level or not. That will be around 50 times a second. Okay, 50 times. If there is any change in the weight, okay, the drone will automatically adjust the level. Okay, so after starting that one, I will show you the basic movement. At that time, I will show you if I am tilting, what is actually happening to the drone. Okay, so if you have any questions, you can ask. I thought of not explaining too much of theory in this session because our objective is to learn how to build a drone. Okay, so I will start the drone and I will show you how the change in weight actually make difference to the drone. Okay. So I'm not going to fly right now. So I'm just going to start the drone. Okay. So I will tell you the procedure for starting the drone. So I have the button in my remote. So first I have to start the drone. Okay. So I'm getting a proper switch on setup. Okay. So what happens if some of the buttons are on the bottom side? See, the left side, my throttle is in the middle, and all the sticks are in the bottom. If you start again, what happens? You are getting an error message. Okay, so at the beginning, you have to make sure that this one at the bottom, and all of the switches are on the top. Okay, now the system is okay. So this is only one thing what you have to take care when you're switching on the remote. Okay, all these switches should be on the top, and the throttle should be in the bottom. Okay, so my remote is on. So the first procedure before switching on the drone, powering the drone, you have to switch on the remote control. Okay. In my drone, I have the flight control unit with an arrow mark. Okay, so this is my front side. Okay, so I'm keeping this to my front side, and I'm going to connect the power. Okay, it will take a lot of current. Okay, the drone is on now. The drone is on now, but it's not going to move, isn't it? So for moving that one, I have to arm. Okay, there's a procedure called arming. So the arming means I'm keeping my left stick to the center. Okay, keep it continuously for some time. Okay, motor is actually on now. Okay, you can see the motors are moving. So you have to be very careful because the rotors are slightly big. Okay, so it is stopped, isn't it? Why? After arming, I haven't given the throttle, so the motor switch off. So I will show it from the other side because it's very difficult for me to take it from there because a bigger propeller size. Okay, so 1 second, I will show you. Okay, I'm arming again. Okay. I give a very little throttle. I'm just lifting that one. So I'm going to push the front side down. If I'm trying to push the front side down, it will automatically lift up. So the weight issue, the system will manage. 1 second, okay. So weight issue, the system will manage in that way. Okay. So if you're trying to push the front side, back side, left side down, okay, without using the remote, what happens is the system will check if it is getting any data from the remote control. Now that there is no data coming from the remote control, that means that's because of some kind of disturbance. The system will automatically try to maintain the normal and the sensor data. Okay, so in that way that will do the leveling part. Okay, then so we explained some of the components other than the frame. Okay, so there is actually a question: what is the best material to make the frame of the drone? Okay, so I will show the drone again and I will explain. So this is the material, carbon fiber material which I use for building my drone. Okay. So this is a heavily used drone. I made this one in 2011. I tried. I think changed the motors 2 to 3 times the motor sets. Then I'm flying continuously. I do flower dropping, that type of things using this one. Okay. So the material is carbon fiber for this one. Okay. So not a very neat system. Okay, in drone, this happens when you making your own drone. Okay, so DJI Phantom, the outer structure is really good. Okay, but for us may not be that much neat. Okay, this is carbon fiber. This is the best material to build a drone. Okay, but that's really costly and very difficult to cut and make it. So when we do training, students usually make the drone with a simple aluminum piece. Okay, you can use an aluminum channel for all the four arms. Then there is a material called aluminum composite panel. It's a ACP sheet. Okay, which is usually used for covering the building, outer side of the building. Okay, or you can use acrylic for making the center piece. Okay, you can use that one, and you can easily build the drone. Okay, now we take only. Otherwise, if you want to buy a frame, we can set that one. Okay, from where we can actually buy the. I'll share my screen and we can see from where we can buy all these components. Okay. So it's almost 1 hour time, 2:23. 1 more hour time. I will try to make sure that you can collect all the components and you can make a drone later. Okay. So I'm in my presentation. 1 second. Okay. So in India, if you want to buy, okay, in India, if you want to buy this kind of components, okay, so we have a site called RC Bazaar. Okay, this is a Bangalore-based company. I usually buy components from this website. Okay, there are other sites too. This is slightly slow. Okay, in between I will show you a brand for motors. Okay, so T motor. This if some of you if you are interested to do some research in this topic, you need a very good quality motors. So this is one of the brand T motor. Okay, you can see they have all different type of motors, and they have very good quality, high quality motors with a higher power rating and lower power rating. These motors are sometimes very costly. See, one motor costs around $300. $300 means almost in India, if you want to import $1 equivalent to 100 rupees, you have to give all the tax. So this single motor costs around 30,000 rupees, but these are very high quality, high efficiency motors. Then you have the electronic speed control units. These are also very costly from this brand, but for research application, research programs, you need all the basic parameters. Okay, how much voltage, current, its performance, everything. Okay, for this type of motor, you will get all those data. The problem with the regular local vendors, the local type of motors, you won't be getting the data that much. Okay. High quality, high power motors, and you will get all the basic parameters, performance parameters and everything. Okay. So here you can see see they are using the curved magnet. This will be connected to the outer structure. Okay, they are not using the flat magnet, curved magnet for minimum air gap between the magnet and the coil. Okay, for improving the efficiency. Okay, so this is having a maximum thrust of 7.3 kg. So single rotor can lift 7.3 kg. Suppose you are using an octocopter, that means an 8 rotor drone, then that can actually carry up to 8 into 7. Okay, almost 50 kg. So this is not a very heavy type of system. There are much heavier 100 kg 20-30 kg payload motors are actually available, and you will get all the basic data, performance data at the bottom. I'll show you that one. So 1 second. Okay. So they usually give the performance data of the motors at a different RPM, how much current the motor is actually taking, specific. 8 centimeter, 8.7 or 9 centimeter diameter. And here you will get all the technical data for different motors. Here you can see you have the motor and giving 48 volt supply. Then you're using a propeller of 28-inch length and 9.2 centimeter pitch. And at 40% thrust, you are getting a 40% throttle, you are getting a thrust of 5 grams. And the torque, it will take 1.8 ampere current. And you will get an RPM of 1584. Okay, all this data you will get. Okay, these data are actually required for the research purpose application. Okay, at 100 percentage, this will be getting 6,352 RPM, 352 grams of thrust. Okay, and you can use different type of propellers. Okay, here they use 28-inch long propeller. You will also get the data of 29-inch propeller. Okay, at 29-inch propeller, at 100% throttle, you are getting a power of 7,130. Okay, so you will get all this type of data from this type of this vendor. Okay, T motor, and I'll show you what we can actually buy locally. So this is the RC Bazaar website. Okay, so first I want to buy a motor. Okay, when you go to the lower side rotor. Okay, I'll go to the multi-rotor. Normal helicopter and normal aircraft both are coming under single rotor system, and these are actually the multi-rotor system. You can buy the frame, or you can actually manufacture your frame by your own. Okay, in my case, as a project, we designed the system in our lab and we fabricated everything. So when you're checking the system, you can actually find out the motors. Okay, so this is one of the motor with the 3110 number. So this one represents the size of the motor, and here you can see the kV value. Okay, so this is just I want to show you how we can actually select a motor. Okay, so based on the power, suppose I want to design a drone which has to carry 1.5 kg payload. Okay, so total 1.5 kg payload. Then you have to give approximate value of around 1 kilo for the frame, motors, and other thing. Okay, so total is 2.5 kg. So 2.5 kg means you have 4 motors to lift that. Okay, so 2.5 kg divided by 4. Okay, you will get almost 650 grams. Okay, then 650 grams thrust you need per motor. Okay, so if you have to get 650 grams thrust, then it is better to select a motor with twice the capacity. Okay, at least 1 kg of weightlifting thrust capacity. And here you can see the configuration. This 12N14P means there will be 12 projections, 12 set of coils in the motor and 14 magnets. Stator diameter, all those things are there. Along with this one, you have to check this parameter. Okay, the maximum continuous current is 26 ampere. Okay, this data is crucial for selecting the unit. Okay, speed control unit. For this case, we can actually select a 30 ampere motor driver. Okay, and the maximum power is 481 watts. And you will get the thrust capacity based on the propeller. Suppose you are using a 12-inch propeller with a 4 mm pitch, you will get a maximum of 990 grams of thrust. Okay, so this is something very close to the 1 kg specification. So this motor you can use it for a 2.5 kg total payload plus the weight of the drone. Okay, that type of a drone you can use this 3110 quadcopter motor. Okay, so the single motor can actually give 1 kg thrust at 50% of it, 50% of it thrust value only you have to calculate. Okay, so this having a capability of connecting with the 4-cell battery up to 14.8 volt. Then you can use 11 into 3.75 inch propeller. So you will get a total thrust of 1260 up to. Okay, so first you have to select how much weight you have to carry. Okay, how much weight you have to carry. Then based on that you have to select the motors. Okay, so this is about the motor. Then from this you will get the data about the propeller. Okay, so if it is based on this value, then you have the 12 into 4 carbon fiber propeller. So you have to go to the carbon fiber. CF means carbon fiber propeller. So I will go to the propellers. So there is actually a question, what would be the approximate price of a drone kit? Okay, so price of a drone kit that depends on your configuration, but basically for the first round of learning, if you can, the major cost of the drone is the cost of your remote control. Okay, so for the simple drones, okay, for the remote control, you have to spend 5,000 rupees minimum for the remote control. Okay, then you need a battery. Okay, battery, we will come to that one. Okay, approximately you have to spend 2,000 rupees for the battery. So it is 7,000. Then the battery charger, good quality battery charger costs almost 2,100. So otherwise a local type of charger is available for around 500 rupees. Okay, otherwise the remote control battery charger costs that much, 2,000 rupees. Then motor and ESC, one unit costs around 1,000 rupees. So if you're buying 4, then you need 4,000. So it will come around 12 to 15,000 rupees for starting a drone project. Okay. So and the RTO pilot costs almost 2,300 rupees. So you can see all the propellers. So here you can see the 11 into 5.5 propeller, 10 into 4.7. 11 into 5.5 propeller costs 135 rupees. Okay, 120, 135. That is the cost of propeller. You will get 2 propellers together, one clockwise and one anti-clockwise. One pair cost this much. Okay, so this is about propeller, motor and propeller. Then you need the battery, isn't it? Okay, so we can check the lithium polymer battery. One major issue with the lithium polymer battery, you can ship it in flight. So only ground shipping. If you want to import from some other country, you have to ship it through ship. Okay, not through flight. Okay, and here you can see the batteries. Most of the time we will be using 11.1 volt, this type of 1800 mAh, 2000 mAh battery is enough for around 15-minute flight of 2.5 kg weight drone. Okay, so one battery costs around 1,380. Okay, if you can buy a little more powerful battery, okay, the cost will be slightly around 1,500 rupees. But if the battery voltage is higher, then the cost will be very high. Okay, if you're going for a 22 volt 5000 mAh battery, here you can see 5200 mAh 22.2 volt battery costs 8145. Okay, for bigger drones you need that type of a battery, and here you can see the specification also 60C. Okay, so battery is a 5.2 ampere battery into 60 times. So this battery can give around 300 ampere current. Okay, so this is about the battery. Then the next part will be the flight control unit. Okay, here you can radio. Okay, radio, I will show you the radio. Then we can go to the flight controller. Okay, so this one very good quality remote control. There's a brand called Radio Link. So Radio Link, one remote control, this cost around 14,900, 15,000 rupees. But this is a 10 channel. Even the same remote control, you can use it for all your robot projects. Okay, from the receiver, you can take the data to an Arduino board, you can program it and you can drive anything using this remote control. Okay, all kind of wireless application, you can use this one. But the basically we can use, if you don't have that much of budget, there is actually a remote control by manufactured by this company, RC Basa. So the avionics RCB6i. Okay, this is actually really good controller. That costs around 4,000 rupees. This again is 6 channel, but currently not in stock because of huge demand. It's very difficult to get it on time. Okay, you have to order little early. Okay, I have I have three remote controls of this brand, and most of the time that's working really well. Okay, so if you have any questions, you can ask in between. Okay, because this is not a continuous theory session. So if you have any questions, we can easily. Okay. Then we can go back to the flight control unit. So that's the one you have to buy, isn't it, for controlling your drone. I have to check it where is actually the controller. RD Pilot is one of the easy to use controller. There are other brands called Pixoc. Okay, other brands called Pixoc, CC3D. Okay, all those type of things are there. So this is a flight control unit with the GPS. Both are together cost almost 7,165. I'm not using a GPS in my system right now. Okay, I have the GPS, but I'm not going to touch GPS to the system. Okay, so usually this one without GPS, this will be costing around 3,000 rupees for the flight controller. So if you're buying only this one, okay, so this is a very good quality controller. Okay, that's why the cost is slightly high. Then you have other controller called Pixoc. It's really powerful. That's a 32-bit controller, microcontroller, STM32 controller they are actually using. So this is coming with a combo pack. Okay, you will get the flight control unit, you will get the GPS, then the buzzer, then then you have the power module, and everything together. Together this cost almost. So this is really good, but the cost is really high. Okay, so this costs around 19,000 rupees. Okay, so this Pixoc, if you're interested to buy Pixoc, that's really good to program it. Lot of additional features are there. You can connect lot of other sensors. Okay, lot of applications are there, but it's very costly. Okay, the original one, so this may be a clone one. Original one costs almost 23,000 only for the controller. Okay, so okay, so there is another question. Is it necessary to use driver for motors in small drone project? Okay, so if you want to make anything fly, you need lot of power. Now, normally, none of the microcontroller can give that much power. So always you need a microcontroller. And most of the time, these motors are brushless DC motors. So you can connect the output of motors directly to a microcontroller. Directly to a microcontroller and drive it. Okay, I will show you that one. Okay, see in this one you have the 3 pins, isn't it? Okay, 3 pin for the microcontroller for the motor. So suppose you are connecting these two to a battery, then it won't drive. Okay, you have to continuously switch the connection. So the driving pattern. So first you have to connect from the give power to first and second. So this will move slightly to one angle. Then again you have to connect to the second and third. Okay, then the third and first one. Okay, in that way you can actually drive it continuously. You have to switch it continuously for driving the motor. Okay, in this one, the basic algorithm, if you're giving positive to the first one, negative to the second one, it will slightly move. You will get an output power in the third pin. Okay, so the electronic speed control is taking the feedback from the third one, and then after moving to the next point only, the second and third will power up. Okay, the second will get positive, third will get negative. At that time, And the next one, on the first wire, you will get the feedback. Okay. Then the third one will get positive. First one will get negative. At that time, you will get the feedback in the next one. So in this way, actually, the speed control is working. So it is not possible to power it directly from a battery, okay, or a microcontroller. You always need a motor driver. Okay. So even if it is a small one or big one, we need that one. Okay, there's a question, is there any provision of internet controlled drone? Can we control a drone using mobile tower internet and mobile as transmitter? Okay. That is actually possible, but you don't think that you can control a drone like, so you can make an application in your mobile phone and you are connecting that one through the mobile tower to your drone, and you can control like moving the stick and you can control the motor. Okay, that may not be possible, but what you can do is you can keep your you can make a software for the drone to fly continuously or hold that position continuously, and from your mobile you can send a signal. You can send a GPS coordinate value to your drone. Okay, so drone will go to that point. Okay, after reaching that point, you can program it such a way that your drone should give a signal back to your mobile phone. Okay, you can attach a GSM module and you will get the feedback. After getting the feedback, you can give another position or something else. Okay, in that way you can control, because you need continuous feedback from your remote control to the drone for proper flying. Okay, so continuously you need data. Okay, continuously you have to control the position for manually keeping your drone at a specific point. Continuously you have to change the stick position. Okay, you don't think that just you leave the direction stick and just you give the drone throttle to one point and drone will stay at that point. That is not happening. Okay, in air, positioning an object in 3D space is very difficult. Okay, always you have to give required control data from the remote control. Okay, there is another option. You can actually position the drone using the GPS coordinate value and the barometer value. Okay, from the barometer you will get the height details, and from the GPS you can actually give a data around approximately 2.5 meter diameter accurate data, so the drone will stay at that point. Okay, so in that way you can actually position the drone or control the drone with a mobile phone. Okay, otherwise it's very difficult to control a drone using a mobile phone. With a mobile phone, it's possible by connecting through Wi-Fi. So continuously, you will get the data back to the drone. Okay. So I will go back to the presentation. I will finish the remaining few more things. Then, other than this quadcopter, okay, I will go to the presentation. Okay, so this is where we stopped in the presentation. So this is actually the battery charger, lithium polymer battery charger. This costs almost 2000 rupees. So you can charge any kind of battery using this charger, and you need this small device. This costs less than 150 rupees. So this is a battery voltage monitor. Okay, you can directly connect this to the lithium polymer battery, and you can measure the voltage of each individual cell. Suppose you have a 6-cell battery, you can check the voltage of each and every individual cells, and you have to make sure that battery voltage is never going below 3 volt. Average voltage of a single cell lithium polymer battery is 3.7 volt. 3.7 volt. If it is below 3 volt, then most of the time you may not be able to charge it again. Okay, so even if you're using your battery, lithium polymer battery for the first time, and if the battery voltage goes below 3 volt, most of the time you may not be able to charge it back to the regular use. Okay, so you have to be very careful when you're using the lithium polymer battery. And for the drone, we have different type of configurations. So you have the quadcopter with the 4 rotors. I4 means you can see the front side, the red part. There's actually single motor is facing the forward direction. And in X4 configuration, you have actually two motors in the left and right. Okay, you'll be the drone will be moving like that. Okay, now single motor will be moving forward. Two motors will be facing the forward direction. Okay, the same way you can use hexacopter, I direction and I and X. Okay, so one motor facing the forward direction or two motors facing the forward direction. Okay, I'm usually following this I direction for my drone because it's very easy to identify which side is front. Okay, so you have the Y6 configuration. In Y6 configuration, you have only 3 link, and we will keep one motor on top and one motor on the bottom. Okay, at the end of each 3 of the link, we will use one motor towards upper side and one motor towards the downward side. Okay, so totally you have 6 motors, but in a tri configuration you will be connecting, and you can go for octacopter. Okay, with 8 rotors. Okay, so these are the different type of configuration, and there is another type of drones, the fixed wing drones. Okay, for the drone, the maximum flight time you will get maybe maximum of 1 hour time. It's very difficult to design a drone above 1 hour flight time. So if you increase in the battery, then the total weight will increase. If you reduce in the battery, the energy capacity that will reduce. So there should be a balance in between, and it's very difficult to fly more than 45 minutes time. Okay, you won't be getting that much power. But what you can do is you can actually go for a fixed wing aircraft. Okay, you can use again same flight control, and you have to upload a different type of program. Okay, so using fixed wing aircraft, you can get longer flight time and you can cover more area, because for the drone the maximum speed is limited, but for the fixed wing you can easily go beyond 100 km/h speed. Okay, so you can drive at a higher speed in this case. Okay, so this is another configuration. This is again a fixed wing aircraft, but you have 4 rotors. There's a combined system, 4 rotors. Front 2 rotors you can actually tilt forward and upward. Okay, if you're keeping all the 4 rotors upward, you can take off vertically, and slowly you can change it into the aircraft configuration. Okay, you can take off like a helicopter. Then later you can fly like an aircraft. So takeoff, landing will be very easy. No need to get a very big space. From the terrace also you can actually lift up this one. Then you can travel very high, very long distance using this type of configuration. Okay, so these are the different type of configurations. So those are the things I want to add in my presentation. So if you have any more questions, I will answer that. Otherwise we can see how the drone is flying. Anybody is like to build a drone after this session? Any students are attending? Flight controller for the fixed wing as well as the fixed wing and drone, both are same. Okay, so you can actually do the configuration. Today actually I was planning to demonstrate how you can actually program the drone, but I updated my MacBook operating system. So the version actually changed, and the mission planner, there's actually software called mission planner, and the mission planner is not supporting my current version. Okay, that is the problem I'm facing. So otherwise I thought of demonstrating the programming part of this drone. Okay, so we use a software called mission planner, and if you want to learn that one, I will show you a video how you're actually programming this one. Okay, so you can after building the drone, after making the physical connection, so making the physical connection is very easy. Okay, just you have to wire it. You can actually check the data, and physically you can wire it. After that, there is actually dead system, isn't it? So if you want to give life, what you have to give? You have to add the software. Okay, so they're actually showing the mission planner software. This is the APM planner software, and APM planner software is programming as well as controlling the drone, and even you can use it for giving data wirelessly using an additional equipment, while it is flying. Okay. So for programming this one, you have to connect a USB cable to the flight controller. So that's a USB, normal USB to micro USB connection. At the right, you can see there is a connect pin. No need to connect that one right now. So in install firmware, here you can see different configuration. Okay, the same flight control can be configured for a quadcopter, for a regular helicopter. Okay, engine-based small normal type of helicopter, fixed wing, or even a rover. Okay, the same hardware, same audio pilot you can connect to a rover, and you can drive a small four-wheel drive vehicle using GPS coordinate value autonomously. Okay, suppose you want to drive a robot for maybe 100 meter long from one point to the other point. You can connect an RD pilot and you can program the GPS coordinate and you can do that. Okay, so this has a different type of drone configuration. You have to select the configuration first. Okay, after selecting the configuration, the software will download the firmware required, the hardware program from the internet. Then that will upload to the flight controller. So this is actually an automatic process. No need to do any more programming or anything. Already available program is there. You have to upload that. Okay. After uploading that program, you have to connect the hardware. Okay, right side you can see see this one. Okay, I will show that one. Okay, so right now top right you can see it's not connected. Okay, after all these things, you have to connect the hardware. Okay, so right now your computer will be communicating with the flight control unit. Okay, then you have to set up everything. Okay, the mandatory setup. You have to select whether it is plus or X type. They made it as an X shape. They use that one. Then the compass you have to calibrate. Okay, so whether you are using the onboard compass or if you're using a additional compass. If you're using GPS, you can select the additional compass. Then you have to calibrate it. Okay, calibration means, see here you can see the flight control. Flight, you have to rotate in all the directions. Okay, so that the compass will get the details about all the three axes, the magnetic flex that of the earth. So we have to calibrate that. We have to tilt the drone in all the direction. Okay. So what I'm doing is I'm doing a simple thing. Keep it horizontal, make a rotation, then keep it one rotate the front rotor. Keep it rotated in all the direction. Okay. So in this case, in this way, for the calibration alone, you watch a YouTube video and do that. Okay. So this is actually very easy to use APM configuration video. Within 10 minutes, you can actually complete the software part of your drone. Okay. So you complete the calibration of compass. Then the second part is the accelerometer calibration. So select it. Keep your drone horizontal. Then calibration, they give all the information. Keep it in the horizontal surface. Then press the space bar. Then it will ask you to tilt the drone to the left side. Okay. Then you have to press the space bar again. Then it will ask you to do the similar thing to the right side. You have to tilt to the right side. So this is the way we have to set the software. Okay. To the right side and press the space bar. Then next you have to keep the nose down. The front side down and press the space bar. And the front side up and the space bar. Okay. Then you have to keep it upside down at the last. Okay. So this is the last position. You have to keep it upside down. Okay. So you have to calibrate accelerometer and magnetometer. And later you have to give the information about the remote control. Okay. So you have to connect the remote control and give the calibration. So after giving the calibration, you have to move all the sticks to the extremes. Okay. So you have the remote control, move all the sticks to the extreme. You will get the maximum and minimum data displayed in your screen. Okay. So the number will be from around 1000 to 2000. So we have to teach the maximum range of all the sticks, all the axes, all the channels to the flight control unit. Okay. What is the minimum? What is the maximum? That you have to teach. Okay. So this is actually 10 channel remote. Okay. Some of the pins are not connected, but the many 8 channels, they have the receiver connected to 8 channels. Okay. Then after that, you have to keep all the pins to the minimum condition. Okay, we can see all the minimum maximum values. If there is any sender, that will show. Flight mode, I use always a simple mode, and here you can see only stabilize. Okay, see the if you're moving the stick, you can see the position changing. You can actually add different mode. Okay, if it's in the middle, if it's the bottom, we'll get the different mode. And in this case, they are giving only stabilized, so-called GPS or all those things you can actually give. It is better, it's mandatory to give stabilized mode at least on one stick. Okay, during takeoff, you have to take off the drone in stabilized mode only. Loiter. Okay. Land. Okay. So land, if you give the land, you have to take off the drone only after the GPS value is set in your drone. You have to wait for some time after switching on. Then if you push that one single stick down, the drone will automatically land. Okay. So this is all about the configuration of a drone. Okay. So it's now the drone is ready to fly. Okay. Okay, this is about the software configuration. You have to program the ESC for the minimum and maximum. There is actually a simple step for that. Okay, so you have to program that one. Okay, ESC calibration, there is actually mode ESC calibration. Only remaining that you have to do. That is enough for programming a drone to fly. Okay, so there is actually one more question. Can we make two motor configuration? Okay, there is actually 2 motor configuration, but it's very difficult to move left and right. Okay, so minimum you need 3 for proper direction control. 2 motor, 1 motor moving clockwise and 1 motor moving anti-clockwise. That is enough for counterbalancing and lifting off, but direction control is very difficult. Okay, so some globe-like structures are there with the 2 motors. I saw some videos of that one, but that is not sufficient for drone basic drone application. Okay, so this is all about the technical thing what I want to. Okay, we can watch one more video of robot application. So drones are extremely good for medical application. Okay, sometimes for emergency medical application, so we can use drones effectively. So an emergency call for somebody's having heart. There's a heart patient. Somebody need special attention. Okay, so they're actually calling the control center. They will send a drone with the necessary medical equipments. Okay, so from the phone call, they will get the GPS coordinate. Okay, so you have to go out in the open space and the drone will come to that position. You can collect it, and they will give the live update. Okay, in a mobile phone call, they will tell what you have to do, because this drone is having a camera, so they can see what is actually happening there. You have to point the drone towards the patient. They can watch what is happening that online. They will give the live feedback through the mobile phone, their call. Okay, so this is a simple device for giving the shock. Okay, so this is a very simple application. This is actually a project by one group of students. Okay, so this is a simple application, and right now DRDO, they recently launched a project called Tethered Drone Project. And right now we saw all our wireless devices, isn't it? Okay, so there are a lot of market for a wired drone. Okay, if you have a drone with a, if you have a drone with a wired connection, there are a lot of advantages. Okay, the major issue with the remote control drone, you can't use it for any surveillance purpose. If the Prime Minister is coming or Chief Minister is coming, at that time what happens is they are actually coming with a with a jammer. Okay, so you may not be able to send the wireless data. So at that time the drone will not fly. Okay, so you can actually make a tethered drone. A drone, the battery will be on ground. You can actually connect the power through a cable. Through that cable, you can actually send the control signals. The remote control data, you can send it wired. So it's very difficult to hack the drone. Okay, so the defense people, DRDO, require that type of a product, and there are a lot of applications for that. And you will get the video data through the wired channel. Okay, you can actually power the drone, maybe 24 hours time. The drone can fly continuously, since it is actually battery operated. Sorry, it's actually tethered operated. Okay, the major problem is with the battery. So no need to use the battery. We may be using a small battery on board, because if there is any technical issue at that time, we have to manage. Okay, otherwise the power will be directly going from the generator. Okay, through cables. But the major issue, you have to use a DC power supply source, and you have to give around 100 ampere supply at 48 volt. You need a very thick wire, and the weight will be very high. But we are also working on that type of a project for building a tethered drone. Okay, so but there are a lot of applications for that. So there is no chance for hacking the video output from the drone, and also not able to the wireless system. It's very easy to hack, and other people can also get into the control system, and people can actually land other drones. And I think a few years back, Predator drone by US Army, that was actually doing surveillance above Iran. They have the technology to land a flying drone. Okay, they actually used a program for hacking the control system of Predator drone, and they landed the drone in their airport. Okay, using their own control. Okay, so those type of things are actually possible with the wired control. Okay, so I'm not taking too much of time. It's 3 o'clock. Okay, 3:05. I will show you how the drone is flying. Okay, then if there is any more questions, I will answer that. By that we will end the session. Okay, so I will fly the drone. We'll fly the drone here. On the ground you can see my line follower track. Okay, line follower test and track. So I have the drone. So I have to make sure that the forward arrow is correct. There's actually an arrow mark. Okay. And I'm switching on the remote control first. Okay, all the sticks are on top, and the throttle is in the bottom position. Okay, I'm not using any switch in the system. The problem with the switch, when you're connecting it, it may be taking around 20-30 ampere current at the beginning itself. Okay, so you can hear the sound, a spark sound. And if you're using a switch, the major issue, the switch will get damaged immediately. Okay, so we are not using a switch. We are using gold plated connector, good quality, high quality connector. So I'm going to arm the system. Okay, I'm keeping the left side throttle button. Okay, to the left side. Okay, so the arming is done. Drones, the motors are moving with a low RPM. So I'm going to lift off. So in this one, I just removed the GPS and there is no compass calibrated. That's why it's rotated. I give a slightly left movement, so there is no control for the rotation since it is not having any compass calibrated. Okay, so I will power it again. 1 second. And the simple logic, what if I have to do if there is any issue with your drone? Okay, land it immediately. Okay, so later you just remove the power, connect it again, then you can fly. Okay, so that's about the drone session. We can do a very small recap. Okay, what are the things we covered today? So for the drone, what are the things we need? It's presenting. Okay, 1 second. So we discussed about battery, power module. Power module is used for measuring the voltage and current of the power supply. So we can actually remotely monitor the data, and the flight control unit is having the capability to store the data, store the flight data. So that will continuously monitor the voltage and current. Then we need the electronic speed control unit or the motor driver. Then we need the brushless motors. Then motor need propeller. Okay, so we use a flight controller for giving the information to all the 4 motors. Okay, that is having the sensor. Based on the sensor data as well as the details from the remote control receiver, the drone will fly. Okay, then you have the RC receiver for receiving the data from the remote control and giving to the controller. And you have the remote control, then battery charger, battery and frame. Okay, frame you can manufacture or you can actually buy from any of the shops. Okay, usually the simple frame costs only 500-600 rupees. Okay, so this is a battery, lithium polymer battery. Then you have the power module, then the ESC, BLDC motor, propeller, and you need the controller, and you need the receiver, then the remote. Okay, then you need a battery and the battery monitor. Okay, these are the components you need in a drone. And if any one of you interested to build a drone, if you need support, we can come to Christ College. So we'll give the list of items what you have to purchase, and maybe it will take only 3 to 4 hours time to build the drone. Okay, within 3-4 hours time, you can build the drone, you can program it, and you can learn how to fly. Okay, so only thing what you have to do is buy a few more propellers when you're flying the kit. Okay, so the initial flight may not be that much good, so that will definitely damage the propeller. So you have to replace the propeller. So, okay, so thank you very much for your patient listening. So I thought of doing the programming part today, but since I have software issues, I was not able to do that. And this is the second session I'm taking in this series. So if you have any doubts, I will share my number. Okay, so this is my number. So if you want to call, you can call me, or you can send WhatsApp message if you need any help. Okay, in this case also there is actually another question: can we synchronize 2 or more drone with the same speed and in same direction? Okay, so for that you need different type of control system. So this type of systems are actually getting data only from one remote control, and in this case all the 4 motors are not rotating at the same RPM. Okay, 2, the problem, if there is any single scratch on the propeller, the efficiency will be less, the air pushing will be less, the thrust will be different. Okay, so at that time the controller is actually controlling the speed and varying the speed and maintaining the thrust. So even if you're driving all the 4 motors at the same RPM, okay, that may not be enough to make the system in the balanced position. Okay, sometimes for the level flying also the different motors are rotating at a different speed. Okay, so the major factor is how much thrust the motor is producing at the time. Okay, not the speed. Okay, thank you, Manish. Manish had a few questions. Okay, so if you have any questions, you can ask. Otherwise, I'm going to wind up the session. Thank you very much to the organizers and Talkers team, EC department under the guidance of Deepa ma'am. And thank you very much for inviting me for the session. Thank you.
Thank you, sir. We're very thankful to you for the brilliant demonstrations and for sharing your valuable knowledge with us.
Thank you.
Thank you. So participants, we have come to the end of today's sessions. Thank you all for joining us today. The feedback is available in the chat box. Kindly fill it. Tomorrow we have this session at 9:30 a.m. Thank you once again. Have a good evening.